Ali, you founded Serve Robotics in March of 2021. It's quite a while ago. Now you're thriving, you're public. What did you see in the market then?
Yeah, thanks for having me, first of all. In 2021, we were actually a team inside Postmates, and at the time, Uber had acquired Postmates. So, really, we were inside Uber. And I had this idea that we should actually spin off, be an independent company, because the robots we're building should be serving everybody, every partner, every delivery platform, because that's you get the best unit economics. But if I go a little bit back further, 2017, when we actually started the effort inside Postmates, it was actually a simple idea. I have a PhD in robotics. I've worked on sensors like LiDAR. We apply them in mining application. We were in DARPA Grand Challenge. And I didn't believe in 2017 that the technology was quite ready for the roads, but it was ready for a smaller form factor. But what we have, these robots are about the size of a shopping cart. They have 3,000 times less kinetic energy than a car. And when I joined Postmates, I could see that the number of deliveries that happen, even in a fairly sparse country like the US, that are just a couple of miles, is actually the majority of them. So more than 50%. In a city like LA, half of deliveries are only less than 1.3 miles. So you can solve basically majority of last mile with a more appropriate form factor. As we like to say, why move a 2-pound burrito in a 2-ton car? That just doesn't make sense anyway. So you can solve the majority of last mile in a smaller form factor with the technology that exists today and start to bring some level of automation to last mile that has lacked for so long. So it seemed like the perfect place to get started with applying autonomy in a commercial way.
In LA, if you look at the 1.3 mile, I'm going to zone in here where I used to live and I coach here, the Autonomous Vehicle Task Force, was the city of Beverly Hills. There's a lot of restaurants in the Golden Triangle. There's hotels, there's apartments, there's condos. Is it delivery food that you're seeing used the most? Is it takeout? Is it perhaps a small delivery from Whole Foods? What are you seeing being delivered?
Well, food delivery is the most popular because we eat 3 times a day. I think after that, you have things like groceries and maybe pharmacy after that. And then, of course, parcels. But the nice thing about food delivery, what makes it nice for us as a first application, but also fairly inefficient in general, is the fact that you need the food right away. So you don't have a ton of opportunities to batch items together. You want your food in half an hour. And that means that most of the time, there's maybe one, maybe two items that someone can grab before they head. Also, restaurants are usually in the busiest parts of town where parking is often challenging and there's not a lot of real estate you can dedicate for this sort of thing. And homes are usually kind of in surrounding areas, most of the density. That's how we design our cities. And then you get into the suburb, etc. But most of the density, most of the demand is actually structured really nicely in places where you don't want to be on the street because of congestion usually. And you actually can access the demand by having a robot on a sidewalk moving at a few miles an hour.
Have you ever seen a scenario? You're at a restaurant. Okay, you don't want to pay for the valet. There's nowhere to park. Ah, okay. I'll park 3, 4 blocks away and have the robot delivered to me where there's no traffic, no congestion. Have you seen a situation like that occur yet?
We have actually thought about this because, again, we were inside Postmates and then Uber. We had the opportunity to really think what the new system needs to look like. I think in a long enough time horizon, that's an entire possible approach because, drivers can be actually supported. If you're going a few miles and a robot can't make it, it might make more sense to have one or maybe more than one robot picking up multiple items, bringing it to a central location where the drivers can wait and they don't have to wait for parking, etc. They can be maybe on a side road or on a dedicated parking. And now they have multiple items to deliver. So they actually become more efficient. I think from a maturity point of view, it's still early days. There's still a lot of short distance deliveries for us to do. But over the longer time horizon, I would absolutely expect this kind of coordinated deliveries.
Today, you're operating on the sidewalks. Do you eventually see perhaps where you're going on the side of the road, say a foot off the curb, a half a foot off the curb?
Yeah, absolutely. I think it's in a longer time horizon. Those are all parts of the expansion plan. We call them kind of road margin applications. Sometimes it's because you want to move faster. Sometimes it may be that there is no sidewalk where you're going, even though most places where we care to operate right now have them, but sometimes they don't. And the form factor we have right now, if you look at the robot, is actually designed to be able to handle that. So it can go like 11 miles an hour. So if you are on the side of the road, you can actually operate there. And it's big enough to be visible, but small enough that it can operate on a sidewalk.
When you're operating on a sidewalk, how are you managing the rules of a sidewalk? There's a lot of custom rules that are not put in any book that you'll find anywhere, just customary that you know. How do you program the robots for those habits, the way that individuals walk on sidewalk?
These are some of my favorite problems actually, because you think about the road, it's challenging in a way that you have a much bigger vehicle moving a lot faster, so a lot more, again, kinetic energy, low margin for error. Sidewalks are way more chaotic though, so there's a lot more going on, a lot of unexpected things. We've dealt with things like goats on sidewalks of Los Angeles. So with that, I think part of it is just having a lot of deference to people, because people generally know how to navigate. If we are in a situation where we don't know what to do, we should just make sure that we are not getting in people's ways and we let them make the decision. So that has actually been a very good strategy in general. Another one is you need language to communicate with other road users. And in this case, it can't be sound. People may not hear it. It can't be visuals. They may not be able to see it. Some people may be visually impaired or hearing impaired. What we found to be probably the most effective is the most universal language, which is body language. So the way the robots act and move can actually communicate their intentions and remove a lot of the confusion. I'll give you one example. When a robot is trying to cross the intersection, it actually starts by almost stepping in very gently. Like it kind of wants to imply that intention that, hey guys, I'm about to start crossing, but it doesn't go like full speed right away. It actually, inches forward so that everybody understands the intention. And then it starts to accelerate and really commit to it. So those are the small things you do that are actually really important in not really damaging that harmony that already exists to the extent that it exists on sidewalks.
On sidewalks, I could see a scenario where you have an 11-year-old child. This is cool. I want to take a selfie with the robot. How do you deal with those types of traffic jams that could occur?
We deal with them all the time. Actually, kids are big fans. I've seen people pull over in their cars and get out with their kids to go take a picture with a robot. Honestly, most of it is very harmless. They just take their picture. I love it. I see them on social media. It actually, I've had cases where parents reached out to us and wanted to go see one of our depots where their kids just were obsessed with the robots in all the right ways. And then there are times where actually there's research on this where kids can bully robots, especially if they're in groups. So the basic SOP for us, which is based on that research, is at one point you start playing dead. So turn off the lights, just stop. Generally, robots are more patient than humans. So you just let them kind of get their curiosity out of the way, and they very quickly get bored. But especially with kids, if they feel like they broke it, they're more likely to just go away. And then sometimes the other strategy is go close to an adult nearby, and that usually helps. But it's really interesting. These are the kind of problems that we actually do have to deal with.
The kids run away and hope the robot doesn't follow them, or an adult and see if they don't get in trouble. It solves your problem there. I want to zone in here in LA because I lived there half my life in Beverly Hills, and you're operating in LA. Where are you operating in LA? And can you cross Sunset? Can you cross Wilshire? Can you cross Olympus?
Oh, absolutely. Yeah. I mean, look, most of those, again, business districts have signals and pedestrian lights. So we are able to basically be just like any other pedestrian there. We are in Hollywood, West Hollywood, Koreatown, Glendale, I think Long Beach, downtown LA. It's expanded a lot. And because I don't personally live in LA, I don't always know the name of every neighborhood, but there's a pretty extensive operation right now. I think hundreds of robots now are in LA alone. And then we have Miami, we have Dallas, we're going to Atlanta soon. And yeah, the robots have been around for years, actually. In fact, the most surprising thing about LA is people are so used to the robots that they don't react. It's like when I'm visiting town, and to me, it's still like, oh my God, look, there's a robot just moving by. And most people are just on their phones and passing by as if they just saw a mailbox. So that's kind of the stages of maturity. It starts with that novelty, but eventually it gets to the mailbox stage.
I guess that Rick Rubin wrote a great book last year. It was about Buddhism. And he said, if you just remove yourself from your surroundings and you actually sit in your backyard and you listen, you hear things. And if you walk around Los Angeles or San Francisco or Miami and you don't stare at a phone, you don't have headphones in, you actually see things and learn new things. And when I look at the markets that you've publicly announced that you're either operating in or you're expanding to, there's a trend here. They're all autonomous vehicle markets. Is that by coincidence? Was that planned? How is that coming about?
Actually, it is. Like, we are not sitting there looking at anybody else. In fact, I think Atlanta was the last announcement that I have to say I was a little bit surprised by. So we announced it, I think a few weeks later, Waymo announced it. And I don't think anyone is looking at anybody else. The fact is, we were working on it for a few weeks, and I'm sure they were working on it for as long, if not longer. And we just happened to find the same market compelling. I think there's some underlying patterns here. For example, we talk to our partners. In both cases, we are working with Uber, for example. We want to know where they have a lot of demand. We also want to know where they have more shortage of labor, their cost, inefficiencies, like all that. So I think those may be the driving factors. The truth is, there's just a lot of places you can put these robots. For the foreseeable future, I believe we are robot constrained, and there's more. Even we could just put all of our robots in LA, and there's enough demand. I don't think we have really touched on this much, but we are launching 2,000 robots by the end of this year. We had 100 by the end of last year, so we are 20xing our fleet size. Today, we are already at more than 300 robots. So in the first quarter, we launched 250 additional. In Q3, we are launching 700 more. And we could have put all of them in Los Angeles. We are expanding because we want to go to new places. We want to learn, new markets. We want to develop our playbook for growth. But the reality is there's just a ton of demand for these. So it's interesting when you see the companies end up in the same cities, and it's probably because of those underlying like labor and demand factors.
You're taking the Waymo playbook. Waymo's constrained in markets now because they don't have enough vehicles, and you clearly don't have enough robots yet, but you're learning in multiple markets. When you go into markets, Uber's an investor of yours. They're also a partner through the Uber Eats division. What kind of data insight is Uber sharing with you for where the demand is for the best places to deploy your robots?
Yeah, we are very aligned in terms of our incentives to put the robots in the right place that gets the most utilization. So we are very collaborative in that sense. I can tell you, before we spun out, when we were inside Postmates and later Uber, I actually had access to historical data of, like, say, Postmates deliveries around the country yesterday. One of the first things I did before the very first Serve robot was launched was actually build a tool that would download that information at any moment and simulate robots at different geographies. So I could literally say, hey, put 20 robots in this location, and then feed the historical data into it and see what the robots would do if they were actually operating there yesterday. This informs so many of our decisions. We've actually been unique in the sense that we knew what delivery looked like better than anybody before we even built the first robot. There were decisions like, how much battery should the robot have? I think generally our industry decided, a few hours would be fine. You can charge the robots in the middle. Maybe you swap the batteries. We ran the numbers and immediately knew that that's not very good for your unit economics. You don't want a robot that's sitting idle halfway through the day. You don't want a human involved in that process of battery swapping. So we actually build robots that can go all day. Our robots can go like 14 hours in a day. Now, the other question is, what is an all-day robot? Do you need to go 14 or 20 hours, or 10 is enough? Turns out anything more than 10, 11 hours captures 90% of the demand. Again, something we knew because we had the raw data to begin with. So we found that information is really, really helpful. So we've been able to focus on the product and know what it needs to be, and not have to change our mind and kind of iterate on some of the fundamentals.
Is it pattern similar to a restaurant? You have your breakfast rush, or your lunch rush, or dinner rush, and then you have your after dinner rush? Is it a very similar pattern to what you're seeing?
Pretty much. I mean, you have restaurants that either are serving lunch, dinner, or breakfast, and then there are ones that just go throughout the day, like coffee shops and desserts and other stuff, ice creams, that sort of thing. So we try to have a diversity so that the robots are utilized, all the hours of the day, basically.
Then that raises the question: how do you deploy your depots? Do you strategically put them around the densest parts of where most deliveries are going to occur? Or how do you pick your depots?
Usually, each depot services multiple neighborhoods, so it's kind of off the beaten path, but not by far. So we don't have to be on a major street where real estate is really expensive, but we need to be within a couple of miles of a few neighborhoods where there's a high business density. And then in the morning, the robots basically go out by themselves. They can go to the neighborhoods nearby. And then at night, they can return home where they get charged, they get cleaned, they get maintained. and get ready for the next day.
From a depot perspective, I'm assuming you're operating a very simple depot. You just have a locked garage because the robots are valuable, and you have charging infrastructure. Is that pretty much it?
That's right. That's pretty much it. And some internet infrastructure. We get the data. Of course, we use the data for training, etc. So when the robots come home, we can offload the data as well.
So on the data standpoint, in your Q1 earnings call, you published a supplement, and you have a licensing partnership with Magna. What are you building with Magna?
Yeah, this actually speaks to a bigger picture question we haven't touched on, which is we are not a delivery company. We are not even a robotic delivery company. We are a robotic company. And what we are trying to do is build robots that can navigate complex human environments. So you have, huge success in warehouse robotics. This has been going for a while, that those have scaled, but those environments are really controlled. So the technology is very different when you leave the warehouse. And then there's the other end of the spectrum, which is the road. So the self-driving cars, again, really different, really unique environments. And we are not going after either of those two, but we are going basically for everything in between, which is places where humans and robots are going to interact. They're going to coexist in the same spaces, which, by the way, is most of the spaces. Now, food delivery happens to be a really good place to get started. In fact, last mile broadly is a really good place to get started because it's very inefficient today. Just to give you a sense, if you order something from China right now to your front door, it costs about $2. But if you order it from Chinatown, it costs $10. So it's a very, very, ideal place to go bring efficiency. And again, starting with the food vertical, and you can expand later. But once you solve last mile and you have a technology that works there, it can do a lot of other things. I'll give you an example. Walmart asked us to do a pilot where we would pick up things from their back office and bring it to the parking lot. This is for people who are ordering pickup and they're waiting in their car. Now, Walmart has pickers. They grab stuff and put it in the bag. The same pickers had to spend more time walking than picking. So they just go to the parking, hand it over, come back. Well, a robot can do that. And we showed up there with the same robot that was working on Sidewalks, but we were 99% autonomous in 48 hours on a Walmart parking lot. It's a similar space. You have the cars, you have the kids, you have the pets. It's all very similar, but in a different application. So our goal is to build the best platform for robots that can navigate complex human environments. And we can't make every form factor of those robots. We should be the one that basically has the killer application using which we build the platform itself, the underlying platform. And then we can give access to other folks. Magna is one of the first where they have access to our platform and they're using various pieces of it. There's actually, I mentioned in our recent quarterly call that we have another partner now, a European major automaker that's doing the same. There are a couple others we haven't announced or named them yet, but we would in the future. So that's the long-term play for us as we build a platform, open it up to more folks.
As you build the platform, now I'm going to give you a real-world example. Daughter goes to school, forgets a book, textbook, or binder. Oh, I got to get in the car and go. It's 2 miles down the road. I'd love to have a personally owned Serve robot that I can put the book in there, send it off to school. Magna has world-class manufacturing capabilities. You're building out a world-class robotics data set. Could at some point, will you sell me or I can subscribe to a personal robot?
What you're pointing out is right now, most things are moving from a central location to the home, but they're not moving between homes as easily, or even reverse logistic of sending something back is kind of a nightmare. So you bring that $10 cost that I mentioned down, you can do a lot of other interesting things. In fact, when people talk about the TAM for last mile, I think it's infinite because it's $10 right now and we're using it so much. If you bring that down to $1, or honestly, because of advertising we talked about, you may be able to bring that cost down to zero because advertising and other monetization sources could actually pay for the robots operating out there. So if you bring that cost down, I can imagine people sending each other stuff. And, when you forget something, and if it's close, a robot would do it. If it's longer, maybe it's a combination of robots and a car or a drone, which, by the way, we haven't talked to. We have a partnership on the drone side as well. So I absolutely see us doing things very differently as this cost comes down.
It unlocks so many opportunities. If you want to send something to a neighbor's house, you have to get in your car. Well, it's a waste of space. It's a waste of time. You could put it in one of your robots. And center, is that drone partnership, is that with Wing?
That's right.
It was really cool. Mr. Pro Junior Ross Pro hosted me at his ranch at Hillwood, and I got to experience a Wing drone in person. That was cool, and that works. So how does the integration with Wingwork, do you take your robot, takes it to the, let's call it the launch platform, and then away it goes, and then it eventually comes out to me?
Yeah, actually, we've posted a video of this. I would tell you the only thing cooler than robots or drones is robots and drones. And we have a video of how this works. Basically, one of the challenges, which is true actually for self-driving cars and drones, is getting to the source in busy environments. Like, again, where restaurants usually are, you don't have a ton of real estate you can dedicate to a drone or a car. In fact, sometimes you don't own any of that real estate around you. And even if you did, there's also the traffic, there's the people around, so they may not like drones coming and going. So what we actually do is we can go to any restaurant. Like right now, we cover 1,500 plus restaurants in areas we are, and we don't need any changes to the environment. We don't need anything special for us. We just incorporate. We just basically get added to the existing environment. And when we pick up the order from the restaurant, we can go a couple of blocks away to a dedicated parking location where there is basically a handoff that happens between our robot and the drone. And you can see a video of that. It's fully automated. And basically our robots gives the package to the drone, which can now go 5 miles in minutes and deliver that to any home. So this is really cool because we can do the short distance deliveries entirely. And then we can also be part of the long distance deliveries and help this technology get to more homes faster.
A restaurant, the individual in the kitchen, they package the food. Do they go to a certain door to put it into the robot? Is there a robot loading zone? What does that look like from a practical standpoint?
Yeah, we can get all the way to the front door. Often restaurants tell us where they want the robot to wait. They actually really like the robots. They have negative experiences when, most drivers and dashers are great people, but every now and then there could be one person who is less than pleasant, and that kind of unfortunately happens every day. So with robots, they can actually tell us what to do. We will go wait where they ask us to. All they have to do is literally step out, open the lid, put the item in, and then the robot kind of secures that, it locks, and it gets going.
Now, on the other end of that equation, there's a customer that ordered that meal. How do they select the option to have it delivered by a robot instead of by a traditional driver?
Well, today actually they get assigned to it. So if you are in, let's say, Miami right now in Brickell, and you order from one of the restaurants we are delivering for, which, as I said, like in total is more than 1,500 today, you would receive a notification after the order is done that it's been assigned to a robot. You do get a heads up before that it might be the case that this restaurant is part of the program, and you do have an option to opt out. But by default, you are able to get assigned, and then when you receive your order, you press a button. You go downstairs to your robot. Basically, you press a button on the Uber apps screen, and it unlocks the lid of the robot, and you can grab your item.
To give you a simple analogy, Uber's the car key, essentially, that allows this to function and unlock. But I got to give a shout out to a very, very dear friend of mine, Mr. Roger Webb. And he calls himself a student in the restaurant industry. His whole career worked in the restaurant industry. And every time he evaluates a new technology in the restaurant or the QSR, the quick service restaurant industry, he says, can it pass the French fry test? And Mr. Webb's whole thing, the French fry test, is if I'm going to order a hamburger French fries, the French fries get delivered, they have to be crispy. So can your robots pass Mr. Webb's French fry test? Will they come crispy?
I believe so. We have our own version of this, which is I would say there are two actually, the pizza test and the ice cream test. So we do ice cream deliveries in 100 plus degree, Los Angeles summers. Our average delivery time from pickup to drop off is about 18 minutes. So the ice cream stays in good shape by the time we are at the customer location. Keep in mind that the cargo is insulated, so that helps with the temperature. The other one is pizza, and there's actually quite an obsession with temperature when it comes to pizza delivery. You really want to keep it in the bag and keep it in top shape by the time it gets there. So we actually did a pilot with Pizza Hut in Vancouver a couple of years ago. And they would measure the temperature from the beginning to the end of the journey to make sure that the temperature is maintained. And again, we could meet, if not exceed, the human delivery quality. But there are more opportunities here, actually. I think in a longer time frame, we could even add cooling and heating to the robots. Right now, as I said, we have 14 hours worth of battery life. And I think there's still more optimizations to be done. That's kind of more hours than we need to operate anyway. As I said, like 10 hours gets you 90% of the demand. So eventually we can even put some of that battery capacity towards having maybe solid state heating or something inside the bin, so that we can really exceed the experience you get by today's kind of standards.
You indirectly answer correctly. You get it. It's all about packaging. Packaging is what's going to allow the French fries to be crispy, the ice cream to be cold, the pizza to be warm.
The coffee not to spill.
Yes, we don't want the coffee to spill. So, do you engineer a special thing for coffee? Because I remember years ago when you were at Postmates, I got to go in the prototype car that you worked on with Ford for delivery. And there's all these different ways to engineer, and there was a pizza one to hold the packaging. If I order, say, a Starbucks, does it come so it's not spilt all over the place?
Yeah, there's two sides to this. So there's the packaging on the merchant side, and then there's the packaging on or the cargo design on our side. So one of the nice things about being part of Postmates when we started this project was we actually had access to all the merchants and partners. So we actually involved them in the process. I remember when we used to make cardboard box version of our cargo design and actually go to LA and put it in front of folks and see how they interact with it. So one of the lessons, which is I think the same thing people learned about minivans, was put a lot of cup holders in there. It always helps. But yes, we basically have the design so that it can bring the items in as good a shape as possible. It does make a big difference on what the container is to begin with. There are cases where the drink is not very secure, and that generally makes it challenging, whether it's a car or a bike or a robot. And there are times, and I've seen Starbucks recently make some upgrades, at least where I am, and man, the packaging is tight. So they have a sticker on top that's really, really strong, and the kind of the size of the lid is really well sealed. So if you have that, in addition to having a cup holder and enough kind of thoughtful design in the robot, you're going to have really good quality.
You have really good quality. I'm sensing here a collaborative nature of Serve Robotics. Right now, you are operating two models. You have the Gen 2 and the Gen 3, which is now going into service. How much input do you take from your customers as you develop new generations of your robots?
Oh, a lot. I mean, customers, merchants, and the delivery platforms are the three stakeholders here. And then the fourth one would be the pedestrians, folks around the robot. So we are constantly trying to understand where are the opportunities for us to make the robots better. I'll give you an example. We were able to fit extra large pizzas in the Gen 2 robots, but getting the pizza in and out was actually challenging. It was just your fingers getting in there was more challenging. So we actually expanded the cargo space. Now you can put an extra large Domino's pizza in there and very comfortably get it in and out. Just as one of the examples. There's a lot of feedback that we try to incorporate into every iteration of the robot. Now, we've been around since 2017, so we've learned a lot of things from the early days that are already incorporated. But as you scale, you always learn new stuff.
It's a better customer experience. How about from a technical perspective? Are there any main differences between Gen 2 and Gen 3?
Oh, yes. It was a really big upgrade. We have more cargo capacity. We have faster speeds. I think the older robots could do like 6.7 miles an hour top speed. This one can do 11. More battery capacity. That one was maybe less than 10 hours. This is 14 hours. But also, it has more compute. I think 5x more compute. It has better sensors. And then to top it all off, it actually has the cost of 1/3 of the cost of the Gen 2 robot. So for basically one Gen 2 robot, we could make 3 Gen 3 robots, despite all these improvements that were made to the specifications.
Is that because of the quantity and the scale, or is there something else with a big breakthrough that caused that? I would say dramatic price drop.
There's a lot of tailwinds here. So first of all, technology gets cheaper. So compute, for example, we could basically pay the same cost but get 5 times more compute, or sensors. So some things are just getting cheaper by themselves if we don't do anything at all. Other things are related to manufacturing. The way we are manufacturing at a larger scale, we can reduce costs. Of course, buying items in a higher order volume helps. Tightening our supply chain, finding vendors that are cheaper helps. And then, of course, design. And we're doing all of this at the same time. So there are parts in the robot that we have redesigned. There are parts where we had an off-the-shelf component that we are now designing in-house to remove the extra margin, basically. And by the way, there are going to be other incremental iterations of the robots where we continue to bring the cost down. So initially, I think we cut the cost in half, and then we came out and announced that we've done another 30% on top of that. So overall, it's going to come down to about 1/3 now. So that process is going to continue. It's, again, a combination of tech getting cheaper, our scale getting larger, and our design getting better.
Which is a positive what your investors want to hear. And from you as an executive standpoint, it's going to allow you to scale and to go new markets, then backfill where you need capacity. When you take possession of the robot from Magna, what type of testing has to be done before you can deploy it? And I asked that because Magna came out in a press release last week and said it's 30 minutes from the time they gave Waymo the vehicle to the time it's picking up a passenger. I was like, wow, okay, that's impressive. Obviously, you're operating on a lot smaller scale, but you have a great partner as Waymo does in Magna. What has to be done before your bots go into service?
Yeah, I am really excited about that partnership because there are few companies that know how to build vehicles better than Magna. We don't need to reinvent a wheel. We don't need to build our own devices when there are others who can do it even better. So we do a lot of the engineering and design work to decide what the robot is and all that. But when it comes to the manufacturing, we have the right partner who can scale this. So I don't have any concerns around whether or not we can scale as a result of that. And one of the things that Magna is really good at is testing to make sure that everything is working as intended. So there's testing that happens on their facilities. And then when we receive the robots, if there's a new generation, if we made changes, or even if the software has changed, we have a very thorough testing process ourselves. So every time we do a software upgrade, for example, we do tests in simulations, we do tests in historical data that we have. Then we do tests in our lab where we have fake sidewalk areas, and we basically simulate scenarios there. And fun little story that I wasn't allowed to share publicly in the past, but I'm finally going to say it. We actually once had a robot escape our testing facility a few years ago. And I have a security camera footage of a robot that just left because it was programmed to seek the sidewalk. It was on a fake sidewalk, and it was just keep driving because we wanted to put miles on it. And then it actually saw the actual sidewalk outside and took off. And we found out 2 blocks later that the robot is missing. So it would be a good social media post one day. But we do all that testing. And then once we are done with that, we go on the sidewalk with a small fleet and test it on a real sidewalk with more human supervision. And then eventually, when the statistics kind of come in and we look at the data and we're happy with the outcome, we roll it out to the rest of the robots.
What you described, the runaway robot, sounds like a Pixar movie. Maybe it's a spinoff of Cars.
It's really good. It actually gets to the edge of the sidewalk, like at the parking gate, and it pauses. You feel like it's looking around, and then it takes off. It's just like picture perfect.
Which is great. And I've always thought that your robots have a resemblance to Pixar, which I think is great because it builds public trust because it has that cuteness factor to it. When you're considering bringing on a new market, let's use Atlanta for an example, because that's a new market coming along. How do you determine the initial ODD of where the robots are going to be deployed?
Yeah, good question. Look, a lot of it starts with the conversation we had with our partners, whether the city or the neighborhood in the city. We want to see where the demand makes the most sense, where the restaurants are. And then, of course, we look at robot capabilities. We have our own ODD definitions. For example, we had generations of robot in the past that didn't have mechanical brakes. They had electrical braking. What that basically meant is you apply current to the motors to stop the robot or to keep it stopped. That wasn't ideal for hilly neighborhoods because what if a robot runs out of battery? Then you don't have a brake. So in the Gen 2 robots, we started adding mechanical brakes. And now in the Gen 3 as well, if a robot runs out of battery, it breaks. So that means our ODD now includes hilly neighborhoods. So we look at those kind of specifications and decide if there's anything that stops us from going to a neighborhood. So we exclude that. But otherwise, generally, the robots have pretty good range. And most of the decisions end up being about where are the businesses, where are the customers.
How about advertising? You have the high rent district, the low rent district. Does advertising play any defining factor of where you're going to initially deploy?
I don't believe we have ever had that as a criteria in the ODD. Generally speaking, again, wherever we go, the busy environments with a lot of people around, and so it hasn't been a factor yet. But generally, we see advertising as a really solid opportunity to bring the cost of delivery down because we don't just reduce the cost of delivery itself. We increase the revenue sources, which means the cost that's passed on to the customers down the line can actually be reduced. But I haven't seen that impact our ODD decisions.
On the advertising front, advertising has become a very quiet and very big juggernaut inside of Amazon. Quarter over quarter, when Uber reports, their advertising business is growing dramatically. Lyft is now building an advertising business. Will you follow that same path as you build your advertising business?
I never thought I would get a PhD in robotics and sell ads. But I think the world just kind of takes you there. When we were inside Postmates, we had one of the most popular merchants in LA, Pink Dot, reach out to us and say, hey, can I put my brand on the robots? And honestly, that gave us a bit of heartburn at first. I wanted to try it, but I went to Postmates leadership and there was pushback. It's like, what about the other merchants? Are they going to be upset? And then we decided to experiment. Just put a few robots out, see what the reaction is. And it turned out to be really positive. In fact, we had merchants that were maybe competitive to Pink Dot, which is a convenience goods store, and they reached out to us and actually wanted to be part of the program. So we found the reception to be really positive. Now the whole industry has adopted this model. So sometimes you just get dragged there when you see the demand. And I found that in a low margin industry, low revenue, low margin, which is delivery historically, it's really nice if you can introduce new revenue sources. And advertising is one of the first ones. We talked about our platform. That would be a future opportunity. Also, the data that the robots collect. We collect more data per day. In fact, 4 times more data per images per day than GPT-4's vision model was trained on. So there's tremendous value on that. And it's not just images, it's paired with LiDAR. It has the robots kind of information and actions included. So there's tremendous amount of value in that. And if we can really take advantage of all this, again, we can bring the cost of delivery that's passed to consumers over time to be a lot less, from that $10 it is today to $1, or maybe one day, even less.
You have a growing advertising business, and let's look at that. You got Alphabet, which is Google, and you got Meta with Facebook and Instagram, advertising juggernauts. Then the data licensing becomes interesting. You hear it on the earnings call after earnings call. Reddit, what's your licensing strategy? That they've got a juggernaut of data under there, and you have something very similar. So what you're telling me is that you could potentially have a robot delivery business, an advertising business, and a licensing business. And so now now you're a highly diversified autonomy business.
That's right. Yeah. I mean, if you look at our revenue right now, I think like last year, maybe half was delivery fleet related. And even there was advertising and delivery fees that was separated. There was some licensing and software services there. And we now have a new recurring software revenue starting in Q2 because of some of these recent partnerships that I mentioned. So, it takes some effort, but we've been very deliberate trying to make sure that we have a diversified revenue base.
As you're diversifying your revenue base, I do want to highlight for our audience here in Q1 2025, your delivery volume, this is impressive, increased 75%. You completed over 100,000 deliveries. What led to that dramatic increase? Was it more robots on the platform? Was it more demand from customers? What led to that dramatic increase?
Yeah, I think we shared Q1, which is 75% increase. And then in Q2, we are projecting another 60 to 75% increase again. So the reason is, as I mentioned, we started building our Gen 3 robots this year. We want to launch 2,000 of them. We have a contract with Uber. We ended last year with 100. We've already built 250 more robots that we added in Q1. And those robots, they didn't get introduced on day one. They came over time. And also when they reach us, there's, it takes a few weeks for them to actually get into utilization. So with all that in mind, the robots were gradually increasing in numbers. And at the same time, we were adding new neighborhoods, we were adding new cities, we were adding new merchants. Our merchants partners increased by 50% last quarter. So we are, as I said, over 1,500 now. So all those have had the impact of lifting the volume. And again, they're going to continue to do that in Q2, even though we are not adding more robots anymore. We're just becoming more efficient. I'll add one more thing, by the way. In the 3 years before this year, where we started adding more robots, we had the same 100 robots. And those 100 robots became, I think, 4 times or more in terms of the delivery volume growth, something like 20% month over month growth, I think is the exact number on average over 3 years. So that was, all by efficiency, just getting better at using the robots. So we have a lot of levers to push right now, and a lot of upside in front of us, basically. Add robots, add cities, add merchants, and become more efficient and better at our job.
You have clearly growth upside, but you've hit the nail on the head. Efficiency. When you can unlock efficiency in business, you can really unlock a good things. Ali, over the next decade, how do you see the autonomous sidewalk business evolving, and what do you see it becoming?
I think it's going to go from novelty in most cities to the mailbox stage, the utility stage, where you don't even notice it. And then it becomes this infrastructure that cities come to rely on. I remember, for example, when COVID happened and we were operating a small fleet in LA, and there was this overnight change where people used to see our robots and say, "What is that?" To they would see the robots and immediately know it's contactless delivery. So there are certain moments where you see this transition in how people, how receptive people are. I think we are going to have this adoption of robots, and it really truly is one of the first truly new form factors of mobility in the 21st century. When you think about these robots, I think delivery robots are what the scooters needed to be, which is autonomous. They are able to move around by themselves. They don't need humans to deploy them and move them and charge them and all that. So this to me is one of the first truly novel kind of form factors that's going to start this process of what I call unbundling the car, because we do too many things with the passenger car that is way too inefficient. And by the way, it also costs lives. Like there's 20 pedestrians dying every single day in the US from car accidents, and we seem okay with that. But if we can remove a quarter of car trips that are about last mile errands and shopping, for example, by having robots like this, well, that's going to save lives. That's going to save congestion. That's going to save on CO2. So we are on this mission. I think we can bring that first truly 21st century form factor to market. And in the next decade, they would become very commonplace and, a fact of life.
They're going to become a fact of life. The thing that you didn't hit on that I'm going to hit on, it'll lower individual stress levels. Oh, I forgot the milk. Oh, I forgot the eggs. I got to get back in and you're stressed out. And let's be honest, when you're stressed out, you drive faster. You don't necessarily pay attention. Boom, you hit a kid on the bike. Well, they're dead. That you ruined your life. Well, if you forgot the milk, you put it in a sidewalk bot. That scenario never happened. And there's a lot of positivity that comes out of it. And then you said this with scooters. The biggest issues with scooters was the sidewalk clutter that as they scaled only got worse. Your robots don't cause sidewalk clutter like the Pixars. They go home to sleep at night. They could be friends with Lightning McQueen. Who knows if they talk at night? Night at the museum, you could have night at the depot, but they go back and they're not there on the sidewalk. Ali, this has been a fascinatingly insightful conversation. As we look to wrap up for today, what would you like our listeners and viewers to take away with them?
I think my message is robots are coming, and they say future is here, but not evenly distributed. This is one of those examples. If you go to LA, it's just the most normal thing, and to most folks, it might be news. And I think if you really take a step back, this is a really interesting moment because we've taught computers to understand us and to understand our world and also communicate with us. This is all the progress in the last couple of years. And those are they have been the biggest missing pieces for robots to enter our lives. So I'm obviously super optimistic and excited about this transition. I think it's going to make our lives better. And, we are going to keep pushing and bringing these robots to more and more cities over the coming months and years.
Robots are scaling. Robotics is becoming a multi-billion-dollar, soon to be $1 trillion business. The future is bright. The future is autonomous. The future is Serve Robotics. Ali, thank you so much for coming on the road to autonomy today.
Thank you, Grayson.